Animal communication has one pretty obvious limitation. For the most part, the animal knows what it means and we don't. But artificial intelligence may be giving us a way to do more than just listen. In the Bahamas, researchers are training an AI model called DolphinGemma on decades of wild dolphin recordings, hoping it can detect patterns no human has noticed. This model listens to dolphin whistles, clicks, and squawks, searches for patterns, and tries to predict which sound is likely to come next. The goal isn't to create a perfect Google Translate for dolphins. Researchers are trying to determine whether AI can detect patterns in animal communication that humans may have missed. Humans have tried to interpret animals for thousands of years. We know that a growl often means back away. We know that a wagging tail doesn't always mean a dog is happy, and that a cat staring directly into your soul while pushing something off the counter while you yell, "No, Mittens, no!" probably isn't experiencing deafness or a motor control problem. Actual translation is much more difficult. Animals don't communicate using sound alone. Meaning can depend on which animal made the call, who was listening, what happened immediately beforehand, and the relationship between everyone involved. A call used during a reunion might sound exactly the same as one used during conflict. Humans can listen to hundreds of recordings and notice obvious similarities. AI can analyze millions of sounds and look for combinations that would be almost impossible for a person to track manually. The Wild Dolphin Project has been studying the same community of Atlantic spotted dolphins since 1985. Researchers know individual dolphins, their family histories, their social groups, and what they were doing when particular sounds were recorded. That context is essential, because a whistle by itself doesn't tell you much. It's the animal equivalent of finding a text message that says, "I'm fine," and trying to determine whether everything is, in fact, fine. Dolphins already produce what scientists call signature whistles. These are distinctive whistles associated with individual dolphins. Similar to names, mothers and calves can use them to locate one another, and dolphins sometimes copy another dolphin's signature whistle while addressing them. They also produce burst pulse squawks during conflicts and rapid clicking buzzes during activities such as courtship or chasing sharks. DolphinGemma was trained using this enormous collection of recordings. It can examine a sequence of sounds and predict what type of vocalization is going to come next. That helps researchers identify repeated combinations and possible structures that may have been overlooked by manual analysis. The researchers are also working on two-way communication. They've developed an underwater computer system called Chat. How original. Rather than immediately trying to decode dolphin communication, Chat introduces simple artificial whistles associated with objects that dolphins appear interested in. And dolphins aren't the only animals being studied this way. Project SETI, the Cetacean Translation Initiative, is analyzing the communication of sperm whales. Sperm whales communicate using short patterns of clicks called codas. For years, scientists grouped these codas into a limited number of basic types, but AI analysis has revealed far more variation. In one study, researchers examined nearly 9,000 codas recorded from Eastern Caribbean sperm whales. The whales altered the rhythm and tempo of their clicks, gradually stretched or compressed the timing, and sometimes added extra clicks. Researchers called one of these timing changes rubato, borrowing a term from music. They found that these features could be combined in different ways, creating what they described as a sperm whale phonetic alphabet. This doesn't mean that scientists can translate a whale conversation. They've found structure, but they haven't decoded meaning. We can see that whales deliberately control and combine features of their calls, but we still don't know what most of these combinations represent. That gap between pattern and meaning is the largest obstacle in animal translation. Even human language has the same problem. Let's use "that's great," for example. "That's great" could mean genuine excitement, mild approval, or that someone has just discovered a leaking ceiling. The words are identical, but the situation does most of the work. To properly understand animal communication, researchers have to connect sounds with movement, behavior, social relationships, and environmental conditions. This approach has already produced impressive results with African elephants. Researchers used machine learning to examine low-frequency elephant rumbles and found acoustic information that helped predict which elephant a call was directed toward. When elephants heard recordings of calls that had originally been addressed to them, they responded more strongly than they did to calls meant for someone else. AI isn't handing scientists complete translations. It's revealing smaller pieces of a communication system. Individual labels, turn-taking, social signals, recurring patterns, and possible rules. This could help researchers monitor endangered populations, measure the effects of shipping noise, and understand how animals respond to habitat loss. But if we learn to reproduce convincing animal calls, we'll move from listening to interfering. Scientists would need rules for when these systems should be used, and whether communication is actually helping the species being studied. Otherwise, we risk developing the most advanced interspecies communication technology and immediately using it to annoy wildlife. Humans are already annoying enough. We don't need to become Kevin the Dolphin's unwanted third wheel. There's also a possibility that animal communication won't fit neatly into human ideas about language. A whale experiences a world shaped by sound, pressure, and long-distance echoes. Elephants can detect deep vibrations traveling through the ground. Other animals depend heavily on scent or frequencies humans can't naturally hear. Translation may not be a matter of replacing one word with another. It may require understanding how another species experiences its world in the first place. AI probably won't let you ask your dog who the good boy is and receive a thoughtful answer. Although, based on current evidence, he's already reached a conclusion. What AI can do is help scientists find structure where humans once heard background noise. Animals have been communicating around us for millions of years. We're only now developing tools capable of noticing how much we've ignored. Although, I'll keep choosing to ignore whatever my cat is staring at in the corner of the room. Liked what your weird brain just learned? Hit subscribe. If not, that's okay. Your cat already told me everything.